Everyone loves those summer days where you can go lay out by the pool where there is sunshine and the sky is clear. And everyone loves watching the sky change colors as the sun sets. Well, have you ever wondered why the sky is blue and why sunsets are red, pink, purple, and orange? First, let's talk about why the sky is blue. When you look at the sky at night, it is black and there are stars lighting it by reflecting off of the moon. So the question is, why does the sky not remain black with the sun acting as another point of light? In fact, the sun is an extremely bright point of light and is much closer to the earth, and the light from the sun looks white, but is really made up of colors of the rainbow. First, let's take the sky out of the equation for a moment and begin by looking at color. Color refers to the wavelength of visible light leaving an object and striking a sensor. The first step in explaining the color of the sky was made by John Tyndall in 1859. Tyndall discovered that when light passes through a clear fluid holding small particles in the suspension, the blue wavelengths are scattered more strongly than red. Next, John William Strutt studied the wavelengths and showed that the amount of light scattered is inversely proportional to the fourth power of wavelength by sufficiently small particles, and blue light is scattered more than red light by a factor which is about 10 times more. Like energy passing through the ocean, light energy travels in waves. Sunlight travels in short waves and other light travels in long waves. The visible light spectrum shows that blue light waves are shorter than red light waves. All light travels in a straight line unless something gets in the way to scatter it. The sunlight reaches the Earth's atmosphere and is scattered in all directions by the gases and particles in the air. Two main molecules in the air, oxygen and nitrogen, are very small compared to the wavelengths of the incoming sunlight, about 1,000 times smaller. This means that they scatter the shortest wavelengths, which are again blues and purples. The daytime sky would actually look purple to humans if it were not for the fact that the sensitivity of our eyes peak in the middle green part of the spectrum. Therefore, a clear, cloudless daytime sky is blue because molecules in the air scatter blue light from the sun more than they scatter red light. And that is why we see a blue sky most of the time. Everyone at one point or another has been in awe at the beautiful purple, pink, and red-orange colors of a sunset. The reason why sunsets are red, pink, purple, and orange is very similar to the reasons that the sky is blue. Scattering occurs by the sunlight striking a molecule in the atmosphere and sending some of the light's wavelengths off in different directions. This happens millions of times before that beam gets to your eyeball at sunset. But at sunset, the light takes a much larger path through the atmosphere to your eye than it did at noon when the sun was right overhead. In other words, as the sun gets lower in the sky, its light is passing through more of the atmosphere to reach you. When we look towards the sun at sunset, we see red and orange colors because the blue light has been scattered out and away from the line of sight. When the blue light is scattered, it allows the reds, pinks, purples, and oranges to pass straight through your eyes. If the air is polluted with small particles, the sunset will be more red. The sunsets over the sea may be more orange due to salt particles in the air. The sky around the sun is seen red as well as the light directly coming from the sun. This is due to the light scattered relatively through small angles. The blue light is likely to be scattered twice or more over greater distances, leaving the more yellow, red, and orange colors. Overall, the sky is blue and the sunsets are red, pink, purple, and orange because of the nitrogen and oxygen particles in the atmosphere. Scattering affects the color of light coming from the sky, but the details are determined by the wavelength of the light and the size of the particle. And that is why the sky is blue and the sunsets are red, pink, purple, and orange.